3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Webb's first official images. It has been over half a year since the James Webb Space Telescope was launched into space on top of an Ariane 5 rocket. The same telescope took decades of work and billions of dollars, all meant to change how we look at the universe and more. After successfully completing hundreds of deployments, alignment milestones, and much more, the telescope is officially ready for consistent science operations. Just earlier today, NASA released the first official images from the James Webb Space Telescope. In the past, the agency released multiple images during different testing phases, but nothing like these. What's even more exciting is the fact that these initial images are just the beginning. Assuming Webb continues to work well, we should expect more fascinating images and data over the next few years. The JWST is the most advanced telescope ever sent into space. Its massive size combined with other unique features also makes it capable of looking deeper into the universe than any other telescope. Here I will showcase the four main images taken by Webb and released only hours ago. After a long wait, the images many of us have been waiting for are finally here. One of the first and most fascinating is Stephan's Quintet, a visual grouping of 5 galaxies. Today, NASA's James Webb Space Telescope reveals Stephan's Quintet in a new light. This enormous mosaic is Webb's largest image to date, covering about 1/5 of the Moon's diameter. It contains over 150 million pixels, and is constructed from almost 1,000 separate image files. The information from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. With its powerful infrared vision and extremely high spatial resolution, Webb shows never-before-seen details in this galaxy group. Sparkling clusters of millions of young stars and starburst regions of fresh star birth grace the image. Sweeping tails of gas, dust and stars are being pulled from several of the galaxies due to gravitational interactions. Most dramatically, Webb captures huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. This proximity provides astronomers a ringside seat for witnessing the merging and interactions between galaxies that are so crucial to all of galaxy evolution. Rarely do scientists see in so much detail how interacting galaxies trigger star formation in each other, and how the gas in these galaxies is being disturbed. Stephan's Quintet is a fantastic laboratory for studying these processes fundamental to all galaxies. Tight groups like this may have been more common in the early universe when their superheated infilling material may have fueled very energetic black holes called quasars. Even today, the topmost galaxy in the group, NGC 7319, harbors an active galactic nucleus, a supermassive black hole 24 million times the mass of the Sun. It is actively pulling in material and puts out light energy equivalent to 40 billion suns. The next image was just as stunning and focused on the birth of stars. This specific landscape of mountains and valleys speckled with glittering stars is the edge of a nearby, young, star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by NASA's new James Webb Space Telescope, this image reveals for the first time previously invisible areas of starbirth. Called the cosmic cliffs, Webb's seemingly three-dimensional picture looks like craggy mountains on a moonlit evening. In reality, it is the edge of the giant gaseous cavity within NGC 3324, and the tallest peaks in this image are about 7 light-years high. The cavernous area has been carved from the nebula by the intense ultraviolet radiation and stellar winds from extremely massive, hot, young stars located in the center of the bubble, above the area shown in this image. The blistering ultraviolet radiation from the young stars is sculpting the nebula's wall by slowly eroding it away. Dramatic pillars tower above the glowing wall of gas, resisting this radiation. The steam that appears to rise from the celestial mountains is actually hot ionized gas and hot dust streaming away from the nebula due to the relentless radiation. Webb reveals emerging stellar nurseries and individual stars that are completely hidden in visible light pictures. Because of Webb's sensitivity to infrared light, it can peer through cosmic dust to see these objects. Protostellar jets, which emerge clearly in this image, shoot out from some of these young stars. The youngest sources appear as red dots in the dark, dusty region of the cloud. Objects in the earliest, rapid phases of star formation are difficult to capture, but Webb's extreme sensitivity, spatial resolution, and imaging capability can chronicle these elusive events. These observations of NGC 3324 will shed light on the process of star formation. Starbirth propagates over time, triggered by the expansion of the eroding cavity. As the bright ionized rim moves into the nebula, it slowly pushes into the gas and dust. If the rim encounters any unstable material, the increased pressure will trigger the material to collapse and form new stars. The third image highlights the final moments of a dying star. The dimmer star at the center of this scene has been sending out rings of gas and dust for thousands of years in all directions, and NASA's James Webb Space Telescope has revealed for the first time that this star is cloaked in dust. Two cameras aboard Webb captured the latest image of this planetary nebula, catalogued as NGC 3132 and known informally as the Southern Ring Nebula. It is approximately 2,500 light-years away. Webb will allow astronomers to dig into many more specifics about planetary nebulae like this one, clouds of gas and dust expelled by dying stars. Understanding which molecules are present and where they lie throughout the shells of gas and dust will help researchers refine their knowledge of these objects. This observation shows the Southern Ring Nebula almost face-on, but if we could rotate it to view it edge-on, its three-dimensional shape would more clearly look like two bowls placed together at the bottom, opening away from one another with a large hole at the center. Two stars, which are locked in a tight orbit, shape the local landscape. Webb's infrared images feature new details in this complex system. The stars, and their layers of light, are prominent in the image from Webb's near-infrared camera, NIRCam, on the left, while the image from Webb's mid-infrared instrument, MIRI, on the right shows for the first time that the second star is surrounded by dust. The brighter star is in an earlier stage of its stellar evolution, and will probably eject its own planetary nebula in the future. In the meantime, the brighter star influences the nebula's appearance. As the pair continues to orbit one another, they stir the pot of gas and dust, causing asymmetrical patterns. Each shell represents an episode where the fainter star lost some of its mass. The whitest shells of gas toward the outer areas of the image were ejected earlier. Those closest to the star are the most recent. Tracing these ejections allows researchers to look into the history of the system. Finally, Webb delivered the deepest infrared image of the universe yet. Webb's first deep field is Galaxy Cluster SMAC 0723, and it is teeming with thousands of galaxies, including the faintest objects ever observed in the infrared. Webb's image is approximately the size of a grain of sand held at arm's length, a tiny sliver of the vast universe. The combined mass of this galaxy cluster acts as a gravitational lens, magnifying more distant galaxies, including some seen when the universe was less than 1 billion years old. This deep field, taken by Webb's near-infrared camera, is a composite made from images at different wavelengths, totaling 12.5 hours, achieving depths at infrared wavelengths beyond the Hubble Space Telescope's deepest fields, which took weeks. And this is only the beginning. Researchers will continue to use Webb to take longer exposures, revealing more of our vast universe. This image shows the galaxy cluster SMAC 0723 as it appeared 4.6 billion years ago, with many more galaxies in front of and behind the cluster. Much more about this cluster will be revealed as researchers begin digging into Webb's data. This field was also imaged by Webb's mid-infrared instrument, MIRI, which observes mid-infrared light. Webb's NIRCam has brought distant galaxies into sharp focus. They have tiny, faint structures that have never been seen before, including star clusters and diffuse features. Light from these galaxies took billions of years to reach us. We are looking back in time to within 1 billion years after the Big Bang when viewing the youngest galaxies in this field. While it has been a massive amount of work in order to reach this point, the results are most definitely worth it. These are only some of the first images released by the agency taken by Webb. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.